In this video, we're going to talk about fractions and decimals. We're going to start off talking about how to switch from fractions to decimals, and then about halfway through the video, we'll switch over the other way, how to switch a decimal back into a fraction. So the first thing I want to talk about is just some common fractions and their decimal representations. So these are the ones you should probably know off the top of your head. So the decimal representation for 1/2 is 5/10. Another one that's pretty common that most people know is 1/4, and that is 25/100. Another one that's pretty common that a lot of people know, and it's mainly because it's kind of a weird one, is 1/3, which is represented as 0.3333 repeating. Okay, just a reminder, the way we write a repeating decimal is by putting a line over the thing that repeats. So in this case, I could have just written 1/3 with a repeating sign over it. It doesn't really matter in this case. Okay, another one that's pretty common is 1/10, and that one's pretty easy because the decimal is said the exact same way as the fraction, 1/10, which is 0.1. We also have 1/100th, which would be a 1 in the hundredths place, and 1/1000th would be a 1 in the thousandth place. Okay, so just based off of this information, you can get some other fractions. So if 1/4 is equal to 25/100ths, then we could think 3/4 equals 3 of those, and 3 sets of 25 would be 75, so this would be 75/100ths. Okay. Same thing, let's do with 1/3. If 1/3 is equal to 0.3 repeating, then 2/3 would be all those 3's, you need to add 3 to it, or 2 times 3 would give me 6, so this would be 0.6 repeating. Okay, so that should all be, other than the 1/3 and 2/3, that may be something that you don't quite remember, but other than that, all that should be pretty straightforward. Okay, another thing we're going to talk about is patterns. There are a lot of super fun patterns when we come to switching fractions to decimals. So, one pattern is, let's find the decimal for 1/9. There's 2 ways to find the decimal for 1/9. One way is to divide it by hand, do 1 divided by 9 and see what your answer is. Another way is with the calculator. So, just for sake of time, let's do the calculator. So 1 divided by 9 is 1 repeating because it's 0.11111. Okay, so 1/9 is 0.1 repeating. 2/9, we can use this idea to come up with the next one, or you could use your calculator, either way. 2/9 is 2 sets of this added together, so that would be 0.2 repeating. 3/9 would be 0.3 repeating, and that should kind of make sense because 3/9 reduces to 1/3. 4/9 would be 0.4 repeating, so on and so forth. 5/9 would be 0.5 repeating, so on and so forth. Okay, so that's one pattern. Another pattern is if I had 1/11th. So 1/11th, to find that as a decimal, I just do 1 divided by 11, and I get 0.90909. So the way we write that as a repeating decimal is 0.09. I don't put a line just over the 9, I put it over the 0.9 because that's the part that repeats, 0.909. Therefore, 2/11ths, 9 plus 9 is 18, or 9 times 2 is 18, so it would be, you can type it in your calculator if you needed to, oh, not 9, would be 181818, so 18 repeating. 3/11ths would be 9 times 3, which is 27.27 repeating, so on and so forth. Okay, another one that's pretty common that you may or may not remember is 1/5. So 1/5 as a decimal, you could type it on your calculator or you could do it by hand, and you get 0.2. So 0.2, so that means 2/5 would be 0.4, 3/5 would be 6/10, 4/5 would be 8/10, and then 5/5 would be 1 whole. Okay, so every single fraction, no matter what, all fractions can be written as a decimal. Okay, so every single fraction, no matter what, can be written as a decimal. Sometimes that decimal might be a repeating decimal. So there's a possibility of a repeating decimal. Okay, so for example, those first three, the 11ths, those were repeating decimals. These fifths were not repeating decimals. They ended. It was just 2/10, 4/10, 6/10, 8/10. Okay, so every single fraction can be written as a decimal. The other thing is not all decimals can be written as fractions. Okay, so every fraction can be written as a decimal. Not every single decimal can be written as a fraction. The reason why is if you think back to Math 1350 when you talked about classifying numbers. If you were in my class, we did a like a Venn diagram looking thing of all the different types of numbers, and we had like integers and rational numbers and irrational and imaginary and real numbers and non, all of that stuff. If you think about it, the set of rational numbers are all the numbers that can be written as a fraction. Okay, so that means that there are some numbers that cannot be written as fractions, and these are the irrational numbers. So irrational numbers are numbers that cannot be written as a fraction. Okay. Another thing to talk about is terminating decimals and non-terminating decimals. So let's define those. A terminating decimal is exactly what it sounds like. It's a decimal that terminates, a decimal that ends. Okay. So it's a decimal that ends, has a stopping point, and we usually represent that with a big capital T. A non-terminating decimal is a decimal that repeats with or without a pattern. That's non-terminating. And I may want to change that word from repeats to continues. It doesn't end. Okay, so the question is, how do we know if a fraction, whenever we are turning a fraction to a decimal, how do we know if it's terminating decimal or non-terminating decimal? So one thing that we need to know about that question, so the question is, how do we know if it is terminating or non-terminating? That's the big question. And you may just say, just stick it on your calculator. Well, just a quick note, depending on the type of calculator, just because, there are some calculators that don't have very many spaces, and so it's hard sometimes to see if it continues or terminates or does not terminate on a calculator. So it's sometimes hard to see on a calculator. Okay, so I have this paper linked in the notes section. If you will print that off, or you can do this in your in your notes if you want to write this table all down. Okay, so we are going to write each fraction as a decimal, and we're going to tell if it's terminating or non-terminating. So I'm going to do a few of them with you, and then I'm going to ask you to pause the video and finish them up, and then we'll come back together and talk about it. If we were in class, you would work with a partner, and you would finish getting all these answers on your own. Okay, so starting off with 1/2. The decimal form of 1/2 is 5/10, and that is a terminating decimal because it ends. Okay, there's no number after 5. Okay, the next one, 1/3, that decimal is 0.3 repeating, and that is a non-terminating decimal because it continues to go on forever and ever, and it repeats itself. 1/4 is another one we know off the top of our heads, 0.25. It ends, it's a terminating decimal. 1/5 is another one we've already talked about, is 0.2 or 2/10, and that is a terminating decimal because it ends. Okay, 1/6, that's one you may or may not know, so you could type in your calculator, 1 divided by 6, and you get 0.166666. So 0.16, the 6 is the only thing repeating, so you put the line above the 6. Okay, that is a non-terminating decimal because it keeps on going forever. 1/7, if you type in 1 divided by 7 on your calculator, this is an example of one that might be a little bit difficult to see if it's repeating or not. This is a non-terminating decimal because it goes on and then it obviously has to stop on the calculator because the calculator doesn't go on forever, so it rounds off the end. But if you look at the numbers, 1, 4, 2, 8, 5, 7. 1, 4, 2, that was an 8, 5, 7. It just rounded it up to 9. Okay, so if I was going to write this as a repeating decimal, it'd be 0.142857 repeating, and that is a non-terminating decimal. Okay, so I want you to pause the video here, and I want you to fill out this form as much as you possibly can. If there's a few that you're confused on, just leave them blank. Resume the video after you finish all the ones you can finish, and then I'll show you the answers to this. So pause the video there. And now that you're back, here are the solutions. We stopped at 1/7. 1/8 is 0.125, terminating. 1/9 is 0.1 repeating, non-terminating. 1/11 is 0.9. Oh, did I say that one? 1/10 is 0.1, it's terminating. 11th is 0.09 repeating, non-terminating. 1/12 is 0.08, the 3 is what repeats, non-terminating. 13th is 0.76923, it's non-terminating. 1/14 is 0.7142885, and that's what repeats, it's not terminating. 1/15 is 0.06, repeating, non-terminating. Up here, these were getting too long to be able to see on my calculator what's the actual part that repeats, but regardless, not the first one, this one with the little dots after it, regardless, it's not terminating. So if you kind of look through that, pause the video here if you need to. Let me zoom out so you can see all of it. Pause the video here if you need to fill in any of them or check it. Okay, so the question is, what makes a fraction a terminating or a non-terminating decimal? So what I'm going to do is I'm going to go through and highlight all the terminating ones. So this is terminating, terminating, terminating. Let's see. Terminating, terminating, terminating. Here, 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 here. So if we were in class, I would then say, what do these fractions have in common? And I would give you a chance to figure it out. Unfortunately, we're not here together, but some of the responses would be, oh, it has to be an even number. And it's like, okay, well, that's true. 1/2 is an even number. I'm sorry, the denominator has to be an even number. So 2 is an even number, 4 is an even number, but 5 is not an even number. And another example, 25 is not an even number. Okay. Another suggestion sometimes is made is, oh, it has to end in a 0, like the number on bottom. In these cases, 50, 100, 250, 500, 1,000, a tenth, those all end in 0. 20 ends in 0, but some of them don't, like 16, 25. Another thing that people might say is, oh, it has to be like a multiple of 5, the denominator, which is the case of some of them, 20, 25, 5, 10, 50, 100, 125, 250, 500, 1,000. Those all end in 5, are a multiple of 5, but the ones that aren't are like 1/2, 1/4, 1/8. And so we would keep on making suggestions until you would probably realize that all of these numbers are a multiple of 2 and or 5. Okay, so it could just be a multiple of 2, it could just be a multiple of 5, or it could be a multiple of 2 and 5. So if you look at this number, this one's a multiple of 2, the denominator's a multiple of 2. This is a multiple of 2. This is a multiple of 5. This is a multiple of 2. This is a multiple of 2 and 5, because 2 times 5 is 10. Here, that's just 2. Here, 20 is 2's and 5's. 25 is just 5's. 50 is 2's and 5's. 100 is 2's and 5's, so on and so forth. So all of these are a number that is either a multiple of 2 or a multiple of 5, or it can be both. Okay? So that's how we know if a decimal is terminating. So here's kind of the way we decide. So the question was, how do we know if it's terminating or not terminating? The first thing you have to do to be able to answer that question is you have to reduce the fraction. Because sometimes something looks like it's not terminating, but after you reduce the fraction, you realize it is actually terminating. Okay, so first step is to reduce the fraction. Then the next thing you need to do is factor the denominator. So factor the denominator is like the whole factor tree thing, and we'll do some examples of this in just a second if you've forgotten what a factor tree is. And the denominator can only have factors of 2's and 5's. Okay, so the denominator, I spelled that wrong. Denominator can only have factors of 2's and 5's. And if this is the case, then it is a terminating decimal. Okay, so let's do a few examples of this. Let's start off with the problem 1/40th. We're trying to decide, does 1/40th terminate? The way that you can decide exactly, because remember, there were some problems on our, here like 1/17th and 1/19th, it was hard looking to see, does it stop, does it keep on going, because I can't really tell on my calculator. So one way you can tell is by breaking down the denominator. So I'm going to break the denominator down into the prime factorization using a factor tree. So I picked two numbers that multiply to give me 40. I'm going to choose 4 and 10. So 4 breaks down into 2 times 2, because 4 is not a prime number. The 2's are prime numbers. 10 breaks down into 2 times 5, and those are prime numbers. And we look at our prime factorization, 2 times 2 times 2 times 5. Those are all 2's or 5's. So that means this is a terminating decimal. It can only have 2's and 5's in the factor tree when you break it down. Okay, another example, if I had 1/60, trying to decide if that is a terminating or non-terminating decimal. So I take the 60, I break it down into the prime factors. 60 is 6 times 10, 6 is 3 times 2. At this point I could stop because I have a 3 and I can't have a 3. But if I kept on going, 10 is 2 times 5. So the prime factorization is 60 is 3 times 2 times 2 times 5. Are there only 2's and 5's in the denominator? No, there is also a 3. This is the problem right here. This is what makes it non-terminating, because there's a 3 in the denominator. Okay, so this is non-terminating. And you can just put T or NT on your homework or test or whenever you're doing these. Okay, and you could check that on your calculator. 1 divided by 60 is a repeating decimal. Okay, let's do another one that you have to simplify. that we need to reduce first. Neither one of those reduced at the beginning because they both had a 1 on top. But let's look at this problem. Number 3, 18 over 750. Okay, so let's pretend like you forgot to reduce. If you forgot to reduce here, you would like take 750. Don't write this down because you could if you wanted to, but this is not the way you work this problem out. But if you didn't realize that it reduced first, you would break down 75 and 10. 75 is 3 times 25. 25 is 5 times 5. 10 is 2 times 5. Looking at this prime factorization, it has a 3. So I would say right here it's not terminating. Okay, this is incorrect. This is actually a terminating decimal. The reason why you can't see it here is because it actually reduces. Okay, so 18 over 750, you can reduce it one of 2 ways. One way is figure out a number that they both divide by. They both divide by 2. You could start off with that if you wanted to. Or if you realized it divided by 6, you could do that also. I'm going to do 2 first. If you were here in class, I could ask you which one you wanted to do, but sorry. So 9 on top, 750 divided by 2 is 375. Okay, and then these both divide by 3 now. So I'm going to divide them both by 3. 9 divided by 3 is 3. 375 divided by 3 is 125. And 125 does not divide by 3. The rule is add the digits together. 1 plus 2 plus 5 is 8, and 8 doesn't divide by 3. So this is the reduced form now. This is what I want to break down into the factor tree. So 125, when I break it down with the factor tree, that is 5 times 25. 5 is prime factor. 25 breaks down into 5 times 5. And those are all 5s, so that means it is a terminating decimal. Okay, so notice, just a reminder, if you didn't reduce it first, you would get that problem wrong because you would think it was non-terminating. And you can double check. Oh, I said there's 2 ways to reduce a fraction. That's one way. You can do it a combination however you want to. You could divide by 6 instead of by 2 and then by 3. Another way, if you have this calculator, you can hit math, enter, enter, and we'll turn it into a fraction for you. 3 over 125. And notice the decimal here, 0.024. That's a terminating decimal. Okay, so if we were in class again, I would then ask, why does this work? Why in the world do you think the rule is it has to have 2s and 5s in the denominator to be a terminating decimal? And I would ask for suggestions, and y'all would all speak up and give your ideas, and eventually somebody would say, because the question is, why 2 and 5? Why couldn't it be 3 and 7? Or why couldn't it be 8 and 15? Or whatever numbers we wanted to use there, or 2 and 3. And the reason why it's 2s and 5s is because place values, all these place values that we're using are in base 10. And think about base 10. 10 is 5 times 2. So that's the reason why it's 2s and 5s. If our numbers were in base 9 or base 8 or a different base, like base 9, 5 and 2s wouldn't tell you if it's terminating or not. It would be 3s at that point that would tell you if it's terminating. Okay? So it's all because it's base 10 system. Okay, so the next thing we are going to talk about is going in the other direction. Okay, so this was all how to go from a fraction to a decimal. Now let's go the opposite way. Now let's go from a decimal to a fraction. Okay, so just a reminder, just a few minutes ago we were going from fractions to decimals, and the way we did that was you do long division, or you could use your calculator, we went a little more in depth and talked about repeating or not, terminating or non-terminating decimals along with repeating decimals. But the main idea of that was, how do I go from a fraction to a decimal? I divide it by hand using a calculator. Okay, the next thing we're going to talk about is the opposite direction. How do I go from a decimal to a fraction? Okay, so there are two ways to do this. One way is using place value. Okay, so for example, if I was had the fraction, decimal is what I want to be doing, had the decimal 0.7. Well, if you read that decimal as you're supposed to, the correct way, that says 7/10. The 7 is in the tenths place, so the fraction here would be 7/10. Okay, another example, if it was 1 and 35/100ths, this is 1 whole and 35 over 100. And you could reduce that to, let's see, they're both divided by 5, so 7 over 20. So 1 and 7/20ths. Okay, so the question is, what about those repeating decimals? So like if I had 0.3 repeating, how do I turn that into a fraction? Okay, so 3 repeating, we know that's 1/3 as a fraction, but how can I get that? If I wrote this 3 is in the tenths place, 3/10, is that the same thing as 1/3? No. What about if I put 33 over 100? That doesn't work either. What about 333 over 1,000? None of them work. Okay, so when you have repeating decimals, you cannot use this method to do it. You have to use the other method, which is actually using algebra. Okay, so let's get started on that. Just a warning, as you start looking at this, this is probably not going to be your favorite thing, but as you kind of get through it, after we do a few problems, hopefully it gets a little bit better and a little bit easier. It might be confusing at the beginning, so just a heads up. Okay, so the first thing I really want you to do is I want you to write down the rule here. Okay, so the rules for this is, it's wordy, it probably doesn't make a ton of sense as you're writing it, but I just want you to have them written down so that if you get stuck on your homework later, you can go back to the rule and see what it is. So here is the rule. Okay, so this is how to use algebra. The first thing, the way we do it is by using a system of equations. So just a reminder, a system of equations is when you have two equations with two different variables and you either do substitution or elimination or graphing to solve them. Okay. We are going to be using elimination when we solve them. So the first step is you set your repeating decimal equal to x, and this is called equation number 1, and that's why I have a number 1 written right there. Step number 2 is you want to move the decimal place enough so that one repeater is in front of the decimal, and you do this by multiplying by powers of 10. Again, this probably doesn't mean anything to you right now. Just write it down so you have it in your notes. Okay, this is equation number 2. After that, step 3, we're going to use elimination to work with the system of equations to eliminate your decimals. So this is equation 2 minus equation 1. And then step 4 is reduce. So pause the video here, write all this out, and then come back after you have it all written down, and we'll do some examples that's going to make this make more sense. Okay, so you should be back at this point from writing down your steps. The first example we're going to do is we're going to show that 0.3 repeating equals 1/3. Okay, so step 1. So I'm going to put, so step 1, I'm going to write step 1 over here. Step 1 says to set repeating decimal equal to x. So I'm going to say let x equal that repeating decimal, and I'm going to write it all out, or write a few of them out. 0.3333, I'm going to put ... so that we know it keeps on going. Okay, and this is actually equation number 1. So let me write a little 1 right here so I know that's equation number 1. Equation number 2 says move the decimal place enough so that one repeater is in front of the decimal place by multiplying by powers of 10. Okay, so the repeater thing here, what's repeating? 3 is what's repeating. 3, 3, 3, 3, 3. Remember when we had like 1, 3, 1, 3, 1, 3? 1, 3 would be the repeater there. Okay, so the repeater here is 3. I want to move one repeater, so 1 3 in front of the decimal place. How can I move 1 3 in front of the decimal place? By moving my decimal place over 1 time. So I'm going to rewrite this equation. X equals 0.3333, so that I don't mess up this equation when I'm looking back later on. Okay, so I want to move my decimal place over 1 time to the right. Okay, the way I move my decimal place over 1 time to the right, I can't just move a decimal place over. I really wish I could, because then my paycheck, that's, let's say, is $500, I'm going to move that decimal over 1 time and make it $5,000. That would be really nice. We're not allowed to do that in real life. The way I can do that on an equation, though, is by multiplying by a power of 10. I needed to move it over 1 time, so that's like multiplying by 10. Let me do a dot instead of a multiplication sign, or an X. If I do it to one side of the equation, the way that I'm allowed to do that is I have to do it to the other side of the equation. So I'm going to multiply that side by 10 also. I get a new equation. 10 times x is 10x equals, this new number is, I move the decimal place over 1 time, so it's 3.3333, repeating forever and ever. Okay, that's equation number 2. So again, equation number 1 is just x equals your decimal. Equation number 2, we moved the decimal place over 1 time to get 1 repeater in front of the decimal place. That 3 is in front of the decimal place now. So now, step 3, so that was step 2. So now, step 3, I want to use elimination to work with the system's equations to eliminate your decimal. So this is equation 2 minus equation 1. So equation number 2 minus equation number 1. Equation number 2 is this, 10x equals 3.333, repeating. Let me go ahead and put a line so you can kind of see the difference between the steps. And then I want to subtract equation 1. X equals 0.3333, so on and so forth. Okay, so when you subtract, I have to subtract both sides. 10x minus x, if you have 10 and you take away 1, you get 9x. On this side, subtract each place value. So 3 minus 0 is 3. 3 minus 3 is 0. It cancels out. 3 minus 3 cancels out. It all cancels out. So every single repeating decimal. That's the whole point of this, is to make all those repeating decimals cancel out. So I'm just left with 3. So now, to solve for x, this says 9 times x. I need to do the opposite of multiplication, which is division. Divide both sides by 9. And I get x equals 3/9. I can reduce that to 1/3. And that's my answer. So that's how I show that the repeating decimal of 0.33333 repeating equals 1/3. Okay, I hope that's kind of cool. I think it's really interesting. You may or may not think it's really interesting. We're going to do a few of those now. So that's the first one. Okay, so if you're like freaking out right now, like you have no idea what's going on, let's just do a few more and then see how you're feeling after that. Okay, so look at number 2. So we are going to convert 0.09 repeating to a fraction. Okay, so this time we didn't actually tell you what the fraction is. We want you to figure out what the fraction is. So step 1, we need to set our decimal equal to the repeating, set our x equal to the repeating decimal. Okay, so we are going to say that let x equal 0.09090909, so on and so forth. Okay, that's equation number 1. And that's step number 1. To find step number 2, I need to move this decimal enough that 1 repeater is in front of the decimal place. So if I have this decimal, I'm going to rewrite it. The thing that's a repeater here is 09090909. So I need to move this in front of the decimal place. So that tells me I need to move my decimal 2 times to the right. So the way you move your decimal 2 times to the right is by multiplying by 100 instead of 10. So I need to multiply by 100 this time. And if you're not sure what number to put there, the shortcut way to know is the number of times you move it is the number of zeros you need to have. I needed to move it 2 times, so I have 2 zeros. Okay, you could also double check this if you wanted to. 090909 times 100 gives you 09.0909. Okay, so my second equation now, equation number 2, is 100x equals 9.090909, so on and so forth. You can put the 0 in front of the 9 if you want to, but you do not have to. That's equation number 2. Okay. And then now, step 3, I want to do equation number 2 minus equation number 1. So equation number 2 is 100x equals 9.090909, so on and so forth, minus x equals 0.090909, so on and so forth. When I subtract them, 100x minus x is 99x. Here, 9 minus 0 is 9, 0 minus 0 is 0, 9 minus 9 is 9, so on and so forth. All of these all cancel out. And I'm left with 99x equals 9. To solve for x, I divide both sides by 99. And I get x equals 9 over 99, which reduces to 1 over 11. Okay, so the big thing I wanted to show you with this example is if you did not get one whole repeater in front of the decimal place, if you only multiplied this by 10x, at this point, this decimal would be 9090, and it wouldn't cancel out at that point. Okay, we need them to line up perfectly, so that's why you have to do a whole repeater. So if you had 3 things repeating, say it was like 1, 2, 3, 1, 2, 3, 1, 2, 3. There's 3 numbers repeating, so you'd have to multiply by 1,000 so that all the decimals would line up at that point. Okay, let's do one more of those. This one's a little bit more difficult. So I just want to go ahead and go over this so that you know how to do it on your homework. So this is number 3. And this one does one thing a little bit different. I'll show you in just a second. So we want to convert 2.3 to 5. The 2, 5 is what's repeating here, to a mixed number. So this time it's a fraction, but specifically it's a mixed number. Okay, so first thing we do, let that x equal out. So we're going to say let x equal 2.3. The thing that's repeating is 2, 5, 2, 5, 2, 5. So on and so forth, dot, dot, dot. Okay, that's equation number 1. Do you notice something different about this specific decimal than the other 2 we've done? I hope that you notice that it has a 3 right there at the beginning. That's going to kind of affect our work a little bit. It's not going to make it super hard, but it's going to change it just a little bit. Okay, so I still do the same thing. That's equation 1. I need to get to my next equation. So I need to move my decimal place. Let's see how many times I need to move it. Oh, 2, 5, 2, 5, 2, 5, so on and so forth. One whole repeater is this right here, 2, 5, 2, 5. That's what I need. I need to move the decimal after that 5. So I need to move it over 1, 2, 3 times this time. To move the decimal over 3 places, we have to multiply by a number with 3 zeros at the end, 1,000. Okay, so this equation now is 1,000x equals 2325, 2325.2525, so on and so forth. That's equation number 2. And notice if we took our equation number 1 and wrote it underneath equation number 2, I'm going to write on this so that it's not making a huge mess on my paper. If I wrote this under equation number 2, x equals 2.32525, so on and so forth. I could do 2,325 minus 2, super easy, and get 2,323. So that was super easy. I kind of struggled with that. But then when I came over here, 2 minus 3, 5 minus 2, 2 minus 5, 5 minus 2, it doesn't line up to mark it all out. So I can't just use equation number 2 and number 1 here because it doesn't line up. Okay, so if you need to, pause and maybe make a little note of that for these types of problems that have that one number in front of all the repeaters. You can't just use equation number 2 and number 1 to make them line up. And you'll see that when you get here because it doesn't cancel out at this point. So I can't do it that way. What I need to do instead is, in this case, I need to make a third equation. Make a third equation. And what I'm going to do here to make a third equation, instead of using equation, I'm going to use equation number 1 to get to it, but I'm going to take equation number 1 and I'm going to move the decimal place over 1 time so that at the end it says 252525. So I just want to move it over 1 time. So for equation number 3 now, I'm going to take this x equals 2.32525, so on and so forth. Again, I want to get this 3 in front of the decimal place so that all of my decimals would now cancel out. So it's just 252525 after the decimal place. So to do that, I have to multiply by 10 here. I have to multiply by 10 here. And I get 10x equals 23.2525, so on and so forth. That's equation number 3. So I'm going to use equation number 2 and equation number 3 now to subtract. So it's going to be 2 minus 3. Equation number 2 is 1,000x equals 2,325.2525, so on and so forth. I want to subtract equation number 3, which is 10x equals 23.2525, so on and so forth. And notice that they line up now. That's our goal. So it's 1,000 minus 10 is 990x. 2,325 minus 23 is 2,302. And the 2's and the 5's and the 2's and the 5's all cancel out now. So now, to solve for x, I'm going to divide by 990, and I get x equals, okay, so this is the part that some people really struggle with. Okay, so let me do, I need to reduce this, and I need to make this a mixed number. Some people like to reduce it first. If you reduced it first, you could reduce it however you see. You can see they're both even numbers, so I could divide it by 2 first. You could reduce it on your calculator, type it in, press math, enter, enter. It reduces to 1,151 over 495. So now I need to make a mixed number. Let me give you a quick little recap on how to make a mixed number, because sometimes this is what people struggle with. And it's just because I think it's ingrained into you so much how to make a mixed number that when you have a huge number like this, you kind of forget what the steps are. So let's start off super easy. Say I had 5 over 2. Well, the way I make 5 over 2 a mixed number is I first divide 5 by 2, or see how many times can 2 go into 5. So 5 divided by 2 equals 2 point something. Who cares what the something is right now? So that 2, that's the whole number. How many times can 2 go into 5? It can go in 2 whole times what's left over. So the way you figure out what's left over, 2 times 2 is 4. I have 1 piece left over. So I have 1 piece left over, and I keep the denominator of 2. Okay? You may use different words. You may use a different approach. It doesn't matter. Just make sure you know how to do that. So let me make it like a bigger problem. What about if it was 149 over 32? Let me see if that reduces. I just made that up. It does not reduce. Okay, so the first thing you do is how many times can 32 go into 149? Well, you can divide it and say, oh, well, it goes in 4 whole times here. Okay, so I know it goes in 4 whole times. How many pieces are left over? Well, to figure out how many pieces are left over, you need to figure out how many pieces I took out for the 4 wholes. And the way you do that is 4 times 32 is So I took out 128 over 32. That's the 4 wholes that I took out. Okay, and so the amount of pieces that are left, 149 minus 128, there are 21 pieces left, and your denominator is still 32. Okay, I hope that helps with making a mixed number. So back here, how many times can 495 go into 1,151? Well, if you typed in your calculator, that decimal should look familiar because that's what we started off with, right? It goes in 2 whole times, okay? So that's the 2 wholes. The 2 wholes that I just used, the number of pieces that is my denominator times 2. So I just used 990 pieces. And when I subtract that, what's left over, minus 990, is 161 pieces. So 161 over 495. So that's my answer. Okay, so I hope that you learned a lot in this lesson. Just a real quick recap. The things that you needed to learn in this lesson: you needed to learn how to go from a fraction to a decimal. You need to be able to recognize how to determine if the decimal is terminating or not terminating. And then you also need to know how to go from a decimal to a fraction by using place value or by using this super fun algebra approach that you learned today. So work on your homework, and that is all available on week 3.